Daha ilk bakışta vurdun mührü kalbime. Yanarım sana, emeklerime yanarım. İşte kuzu kuzu geldim, dilediğince kapandım dizlerine bu kez gururumu. Ateşe verdim, yaktım da geldim. Hello everyone! Today we're going to review Anycubic's 3D printer Kobra X. Our first encounter with Anycubic dates back exactly 6 years ago. Back then, when people talked about resin printers, almost no other brand besides Anycubic came to mind. Since I was going to use a resin printer for the first time, I chose the Photon S. Even though I was a beginner, I managed to produce some really nice work. On the FDM side, however, they didn't seem very ambitious. That is, until they introduced the 4 Max Pro 2.0. Back then, in 2021, I put this printer, which was one of the devices close to the semi-industrial class, through its paces and did a detailed review. Immediately after that, I used the printer again in another project where I explained the differences between open and closed case printers. And on the FDM side, that was the last Anycubic printer I used. 5 whole years have passed since then, and now I'm here with the Anycubic Kobra X. It was a model that was asked about a lot. People were curious about how it compared to different brands, its advantages and disadvantages. The same was true for me as well. All of them have been tested. I hope that by the end of this video you won't have any unanswered questions about this device. Now, as always, let's start by taking a look at its design and technical features. In terms of design, the printer doesn't offer much beyond the usual criteria. The main body, which has metal carriers on the Z-axis, is made of plastic material. On the front right side, there is a 3.5-inch color touchscreen. There isn't support for many languages. However, it's not difficult to use at all. You quickly get used to the interface and can use it comfortably. The build plate has a flexible PEI coating and can be used on both sides. On this plate, we can print objects with a width, depth, and height of up to 260 millimeters in a single piece. Leveling is completely automatic. The nozzle touches 49 points to determine the required height at each spot. During printing, it uses the height map it creates to ensure the first layer is flawless. It wouldn't be wrong to say that the print head is completely different from the systems we've been used to so far. This direct drive extruder system renders systems like AMS or CFS unnecessary. It can perform color changes without the need for an extra module and does this much more efficiently compared to other single nozzle printers. You can also change the nozzle in an extremely practical way. The fact that the nozzle is independent from the hot-end system makes this most frequently replaced part of 3D printers much more economical. When we look at the company's comparison data with the Kobra 3 version 2, the distance at which the filament is cut has been reduced by 52% and the filament change time has been reduced by 81.25%. This means less filament waste and shorter print times compared to its counterparts. The Anycubic Kobra X is one of the fast 3D printers that can reach a maximum print speed of 600 millimeters per second. Its movements are carried out on the Z-axis with a trapezoidal lead screw and steel rods, on the X-axis with a linear rail, and on the Y-axis with steel guide rails. The printer has wireless connectivity. It is possible to connect the Kobra X to the same network in your home office or control it via the cloud, and to monitor prints thanks to its integrated camera. This camera is also AI powered. It has the ability to detect possible print errors and stop the print. When this printer arrived, the thing I was most curious about, and I'm sure you are too, was this ACE Gen 2 print head. As I mentioned earlier, they claim that they've solved color printing inside the print head itself, without the need for boxes like AMS or CFS. But how successful is this? How efficiently does the system work? I already had a few questions in my mind. I immediately turned on the device and set it up. I subjected it to a color print test that lasted over 30 hours. I'll be sharing the color print test with you in a bit, but I want to go in order. First, I'll show you some test prints I print with PLA. After seeing those, we'll move on to the color print tests, and we'll also look at the differences between this printer and similar ones like the i7 or the A1, which you are probably curious about as well. Are there really significant differences? We'll see all of this together. There were some G-code files inside the printer. These were various small test models like toys and the Benchy boat. I printed them using Anycubic brand filaments. By the way, this was my first time using Anycubic filament. I had the chance to use different types, including PLA, PLA+, and PLA high speed. The filaments were quite good. My impression is that they are of above average quality. I didn't encounter any serious problems with the prints I made. The surface quality is quite nice. Even at standard speeds of 200 to 300 millimeters per second, I didn't notice any significant vibration effects in my prints. There was just this humorous print I made to throw away filament waste. There's a small line visible on a tiny spot of it. In fact, I printed this twice. A line appeared in the same spot both times. It's probably related to the model or the settings I used. Overall, the top surface quality is quite good. I did notice a small amount of stringing in a few tiny spots. But overall, all the test prints were successful. Then I printed this dragon model, which has become something of a classic for me and which I print on every printer. For slicing software, I used Anycubic Slicer. Anycubic Slicer is already a software based on Orca, so if you have previously used software like Orca, Bamboo Studio, or Creality Print, you won't find it unfamiliar at all. This print was also printed with the standard Anycubic settings, that is in the range of 200 to 300 millimeters per second. It's quite successful. So, for a print at these speeds, the vibration effects are at reasonable levels. The sagging isn't too much, but I can't say it's minimal either. Since this is a model I printed without supports, there are naturally some sagging areas here and there. In some parts, especially around the dragon's head, I can say there's a bit more sagging. As I observed in the small test models, there is also a slight amount of stringing here. However, these are just minor things that caught my eye. Overall, it's an extremely successful print. This print was also made at the maximum height the printer can handle. Now, I want to show it to you in real life as well. I always conduct the test this way. Another PLA print is the robot model that's currently sitting on the printer. The person who made it designed it based on the features of the Kobra X. You can already see the Kobra X and Anycubic logos in various areas. Other than that, on the shield part, it shows 260 by 260, which is the maximum print size of the Kobra X. There is nothing negative I can say about its quality. It was made up of many parts, and all of them could be printed without any issues. Although most of the print was made from PLA, there were also some TPU parts at certain joints. In a moment, I'll also share my thoughts and experiences about TPU with you. When all the parts were assembled, I think a really nice robot came out. I can't quite remember the number of parts right now, but I will definitely write it here. If you get this printer, or even if you don't, but have other printers, you can print this model just for fun. You can assemble this robot just like Lego Technic pieces, snapping them together without needing any glue at all. To be honest, I really enjoyed making it. The designer is already Maker Online, so they've also uploaded the assembly files to Anycubic's 3D archive. It was quite enjoyable. If you like things like this, you can print it out and have a good time for a while. Some of the parts were also printed in color. The shield, as well as the parts on the leg or upper section that say Kobra X or Anycubic, were printed in color. I didn't encounter any issues or problems here either, and it was already a short print. I also made some full bed color prints. Here, as you can see, there are small Garfield and dog keychain models. They were also long duration prints, so it was a good test in that regard. As always, we checked the surface quality with every print. Of course, one of the most important points was how clean the color transitions were. To be honest, I have to say I was impressed by the color transitions during the prints. If you've previously done color printing, you know how much waste and time loss occurs during cleaning. But with the Kobra X, this only happens once. So for example, is it going to switch from brown to white? It does the cleaning in a single pass and then continues printing from where it left off. And it has done this almost perfectly. Out of all these prints, I only noticed one or two tiny flaws at the color transitions, and that's probably not because there was waste left inside the nozzle, but rather because there was a small piece at the tip. Other than that, I can say I achieved an almost perfect result. The spread on the bed was also not bad. They all stuck. The prints were taken properly, but there were still some minor flaws. I already performed the bed test. We'll talk about that in a bit as well. Apart from these, there were also a few color print tests included with the printer. To be honest, one of them really disappointed me. In fact, I even made a post about this on my Instagram account. Those who follow me have probably already seen it. If you don't follow me, I'll write the name of my Instagram page below. Not the link, but the name. You can follow me there if you like. Usually before review videos, I share things I like or dislike about the devices. But in the review video, of course, I mention all of them collectively. Now, I did a print. There was a clear axis shift and a serious one at that. Even on the prime tower, the tower used to clean the nozzle, there was the same shift. I thought, that's odd. I mean, I've done so many prints, even longer ones. There were no problems with those. I thought, let me print this one more time, it could happen. Of course, even if it didn't happen again, I was going to show you this as well. I did the second print, same spot, same layer, same shift. I said, okay, here they couldn't set up the G-code properly. There's a skip here, there's a problem. I went and found the STL of the model. In fact, it wasn't painted, it wasn't colored. I did the coloring myself and printed it. You can see both of them side by side right now. There's a very significant difference. While one had a shift, the other was printed just as it should be, perfectly fine. There are still some minor stringing issues. You can probably see them on these horn parts. Honestly, I couldn't really solve that issue. It's not a big problem, but the device does cause some minor stringing, I can say that. I've experienced this before with different brands as well. So they really need to pay close attention to the G-code file that's put into this. So I can say this to Anycubic as well with a clear conscience. Now you bought it and you put in 4 filaments. You think, let me just try a small test model inside to see how much waste it will produce and what the quality will be like. They've set it up, right? You think they've set it up really well. This will be the first print you get. Whoa, axis shift. Maybe like me, you'll try one more time and then again. Maybe before you try a third time, you'll call the place where you bought it. You'll say that there's a problem with your device. So you need to be a bit careful. If you buy it too and they haven't released an update, you might encounter such a problem. Just keep that in mind. I also made 2 WhoForge color prints. Prints like these, which look like paintings, are called WhoForge. Honestly, I really enjoy making prints like this myself. Here, there's an image of the legendary rock band AC/DC. It turned out quite well. I can't really say that there are a lot of nozzle marks on the top surfaces. The other one, as you can see, is an elephant head placed inside the map of Africa. I think both of them are really nice. Now let's get to what I think is the most important part, and that is the longest color print test. It's the test with the most color changes, and since I've printed the same model with other similar printers, it's also a print we can compare. This Ninja Turtle model you see has now become a standard test model for me, because now all the new 3D printers come out with color printing. So I wanted to at least create a standard model so that we can clearly see the differences between previous and future prints, or at least the differences between printers with similar technology. I'll be showing you the print quality right now as I'm talking. If you ask me, it has a pretty nice print surface. It didn't cause any problems in the other prints either. At this point, I got exactly the result I wanted. You know how I said it does an almost perfect color change? There's a small color change error right where the neck is. Most likely, as I mentioned, it couldn't clean the tip of the nozzle. That's why it left a very small residue. Also, there's a tiny bit of stringing between the band it wears over its eye. With this model, I usually saw the most vibration effects on the face area. It's present at reasonable levels on the Kobra X as well. This print was also done at speeds of 200 to 300 millimeters per second, so I can't say I see this as a major issue. The print quality is fine, it's good. I mean, there were some minor flaws which I already showed. In my opinion, they're insignificant, but there are aspects where the Kobra X is more ambitious. I've mentioned this a few times at the beginning of the video as well. It claims that compared to its counterparts, it produces less waste. It also says this affects my speed, that I can print faster, in other words. Let's see if that's really the case. I made a video recently. I compared 5 or 6 printers with each other. If you haven't watched it yet, you can access that video from the tag above or the link in the description section. The common print used there was actually this one. Now let's also compare the Kobra X with its counterparts or competitors. How did the results turn out? Previously, I had used the Bamboo Lab A1 and Creality Spark Xi7, which have similar technology. According to the data I obtained from the previous video, the A1 used a total of 537 grams of filament to produce the same print, 111 grams of which was for the prime tower, and completed the print in 48 hours and 30 minutes. The Creality Spark Xi7, on the other hand, used a total of 471 grams of filament, 100 grams of which was for the tower. The print time was 46 hours. The eagerly awaited result? Let's see how well the system actually works. The Kobra X used a total of 430 grams of filament, 71 grams of which was for the prime tower, to produce this print. And it completed the print in exactly 34 hours and 39 minutes. By the way, these figures are not theoretical. As I mentioned, the prints were made, the waste was put into bags, all of them were weighed, and that's how I'm presenting the data to you. Does the system work? Yes, it does work to some extent. By the way, the i7 also made such a claim. They also say we shortened the distances so our waste amount is less. When we compare it with the A1, yes, I think the difference has started to widen. The i7 had also widened this gap a bit. With the Kobra X, this gap has started to widen even more. As for the printing time, there is a much more significant gain. Of course, we are going with just one scenario. So as the prints change, these times may increase or decrease, but the increase in the amount of color change probably makes printers like the Kobra X and i7 more advantageous at the moment, especially when compared to the A1. It's not actually a topic I'm very curious about, but you are asking questions about this. Electricity consumption, again in that same comparison video, I also talked about the electricity consumption of different printers. Let me also give you the electricity consumption information for these three printers. In the test I conducted, there are 4 color changes in each layer. Because during this process, the heating and cooling of the nozzle could affect electricity consumption, I carried out the test this way. According to the results of my test, the hourly electricity consumption of the i7 was measured at 0.1 kilowatt hours, the A1 at 0.09 kilowatt hours, and the Kobra X also at 0.09 kilowatt hours per hour. One of my new tests is the stability test. I print the same model multiple times and test whether it delivers results of similar quality. Here you see one of the prints that has become a standard for me. I specifically choose a model with light supports so that I can observe both the difficulty and ease during removal. Of course, this is also related to the settings, but I use the standard settings. I also want to observe how much sagging occurs. First of all, the surface quality is quite good. The supports were removed very easily and sagging is almost non-existent. Of course, what mattered to me was whether it could maintain the same consistency in every print. I didn't experience even the slightest problem with this. The same print could be produced 5 times in a row with the same quality. Yes, it was another print made with PLA. We just can't get away from PLA. By the way, there are so many prints in front of me that I've forgotten some of them. Here's one of the colorful prints. Here's another toy print which comes with ready G-code and features a color change once on each layer. It's a very nice print. There's no issue with this one either. One of the important prints for me was this one. Well, you could call this a waste bin. You attach this to the side. You can have it hit a certain point and collect the waste inside. I printed this thinking it was just a tiny little part. You know, like you attach it to the end, it hits there and the waste falls down. Its shape kind of looks like that. I thought I would just attach it to the side like that. Then I saw that it was actually a huge print. But the print quality is really nice. I recommend it to you as well if you decide to get one. It's actually quite sufficient. Since the amount of waste isn't that much, it's enough even for long prints. I'll continue with PLA again, but this time I want to talk about carbon fiber reinforced PLA. The printer's nozzle is made of hardened steel. It can heat up to 300 degrees. So you can use many carbon fiber reinforced filaments. PLA is one of them. Actually, there's some confusion about this topic. I've shown carbon fiber tests a few times in my Instagram posts as well. A few people messaged me saying, hey, can you print carbon fiber on an open frame printer? That's what they said. When I heard this from a few people, I thought there must be some misinformation here. Someone must have said this in their videos. Clearly, some incorrect information has been circulating. You can use carbon fiber reinforced PLA in printers with hardened steel nozzles. But if you're using PLA, then carbon fiber reinforced PLA. If your printer can use PETG, then PETG, but for example, ABS. I've done some experiments, I'll show you in a bit, but you can't use a carbon fiber reinforced ABS. PLA and PETG can easily be used in open frame printers as well. What you see here is a model designed and made to hold remote controls. It's functional and nice. We usually toss remote controls around and can't find them. I think having a fixed box like this in one place makes perfect sense. Some of you might even be using similar things at home. It turned out to be a very nice print. The surface quality is excellent. There's not the slightest problem in the layers. Actually, I've noticed this over time. Carbon fiber reinforced filaments are quite something. I guess they hide errors. I mean, I can say that I almost never get a faulty print with carbon fiber reinforced filament. This is also one of the extremely successful ones. I also have a print made with carbon fiber PETG. As you can see, it's a functional part. By changing the attachments at the end of this part, you can turn it into a handsaw or a screwdriver. It had more than one part. All of them were printed at the same time, and as you can see, there isn't the slightest flaw. An extremely successful print. I made a few more prints with PETG. I mean with regular PETG, not the carbon fiber one. Let me show those as well. I focused on functional parts. One of them is a print I made to organize the cable at the back of the printer like this. Another one is a model designed to be attached to the end of vacuum cleaners so that if dirt or filament scraps accumulate on the rail part of the printer, you can clean them. Another one is a colored PETG print. There isn't much color transition, but as you can see, I used orange and blue PETG at the same time. This is also a small but quite nice and functional tool that you can use to clean the grooves of the linear rail on which the print head moves. Of course, I talked about the functions of the parts, but I didn't mention their quality. However, I am extremely satisfied with the quality of all the PETG prints I received. In some of these color transitions, there are mottled spots. That is actually a situation related to the homogeneity of the filament. Other than that, the print quality was quite good. Also, I really enjoy printing functional parts that I can use especially on the printer itself. I mean, I also enjoy printing these kinds of things in my daily life. PETG is also a very nice material. Its flexibility and everything are amazing. It doesn't break or anything. So the first thing that came to my mind when I first looked at this printer was this. Okay, this print head is really nice. I mean, there's no CFS or AMS for color changes. You've solved it in the print head, but then there are those filaments placed on top. You put them in once, and here you're adding a 4-kilo weight. These filaments are slightly leaning back, so they're not positioned exactly in the center either. And our print bed is movable, especially if we're printing at high speeds. Now, this printer can reach a speed of 600 millimeters per second. In practice, it's hard to reach this speed, but let's assume the bed is constantly moving while printing at high speeds. And these are actually constantly vibrating up there. So I wondered if this might turn into a problem over time. Or even if it doesn't become a problem over time, would the vibration have a negative effect on us right away? That's what I was thinking. First of all, they've made this profile quite sturdy and thick to address that. So when I try to move it, the profile itself doesn't move. Of course, the printer moves, but the profile doesn't. This part is very sturdy. Still, I thought, let me print a part for this. And with just a little research, I saw that there are many people who think like me, so I printed these parts you see here. You attach these to the back of the printer like this. This supports those things. This supports our vertical profiles and definitely has a positive effect on the printer in terms of vibration. Again, I chose PETG because of its flexibility, especially since these parts here need to flex a little. When attaching and detaching, they latch onto the profiles. That's why I printed them with PETG. The prints turned out really well. There are no issues at all. Since it's also a durable material, I think printing with PETG was very appropriate. Here, I tried something different as well. For example, I used PETG and PLA at the same time. I'll show you up close now. There's a small support right here. I chose the top layer of this support to be PLA. The reason is that PLA can be removed much more easily than PETG. Also, I wanted to do a small test using it as a support material. I wanted to print using 2 different materials. I was quite satisfied with the result. And now we've come to the ABS print test. Let me explain for those who don't know. Here's a very brief reminder. Printing ABS on open frame printers is actually not efficient. There may be problems with bed adhesion. There can be cracks between the layers. Especially with sharp parts, the corners and edges may lift up. Even if you print and don't encounter any of these issues, there will still be a decrease in the mechanical properties of the material. So why did I do such a test? I usually always recommend this. We have an open frame printer. The nozzle heats up to 300 degrees and the bed to 100 degrees. Now this temperature range is sufficient for ABS. But as I said, it's still an open frame printer. Still, by using adhesive, if needed, you can get small prints, if you also have a good print bed. I want to show you some examples of this. I printed a few pieces that can be used functionally. All of them were printed at the same time. As I said, I had applied adhesive to the print bed. I usually prefer to use hairspray. I sprayed the hairspray. I set the print bed to 100 degrees and started the print. Of course, to make adhesion easier, I also added a brim around it. And as you can see, I also completed the ABS print test with these small parts, some of which have quite sharp edges without any warping or lifting from the print bed. I'm also extremely satisfied with the printer's performance and surface quality here. The filament I struggled with the most on this printer was TPU. In fact, I struggled with it even more than ABS, which is already a difficult material to print. Flexible filament is a challenging material to work with. Of course, a printer with a direct drive extruder should actually be able to print TPU, but since there's a different system here, I got confused myself. Because after I loaded it, it started causing problems after flowing for a while. The printer indicates that the nozzle is clogged. I remove it, feed PLA, and it works. I try TPU again. Even though I tried several types, it didn't work at first. Later, I removed the PTFE tube and printed that way. It wasn't easy. I had to lower the speed to 25-30 millimeters per second. However, as you can see, the prints came out quite well. As I said, it was difficult and took some effort, but in the end, the printer allowed me to print with TPU. These parts you see here are also functional parts. You attach these to the feet under the printer. They are modeled as anti-vibration foot parts. Especially if you're considering buying this device specifically for TPU printing, I'm not 100% sure. I can't say you can buy this printer for TPU with your eyes closed, absolutely guaranteed. It does require a bit of effort, but as I said, you can remove the PTFE tube. Maybe a bearing system could work for this, because the extruder shouldn't pull the TPU too much. If it moves smoothly, you can get a print. Apparently, you can also do color printing, but not with a TPU of 95A hardness. According to what I saw on Anycubic's website, you can get color TPU prints with a TPU filament of 68D hardness. Overall, I like the Kobra X. In my opinion, even just the ACE Gen 2 is one of the features that deserves appreciation. Of course, I'm saying this because it works very smoothly. You saw the tests I conducted. Although I couldn't achieve results like twice less waste or twice the speed as stated on the company's own website, it's clear that it holds a more advantageous position compared to its competitors. Some users don't want their filaments to be left out in the open. This is of course a reasonable request to protect the filaments from moisture and dust. There can be more than one solution for this. The most cost-effective way would be to print the box with your own printer and integrate it into the existing system. By adding silica gel inside the box, you can also protect it from moisture to some extent. The other and more expensive solution is the Ace 2 Pro. Of course, while it can be a more professional solution, the fact that it also has a drying feature up to 65 degrees is an advantage. Additionally, if you wish, you can connect up to 4 ACE 2 Pros to this device. In this way, though I'm not 100% sure if you'll ever need it, you can increase the number of colors in your prints up to 19. In my test, there were prints that covered most of the build plate. During these prints, although it didn't turn into a major problem, I observed that the nozzle stayed close to the plate at many points. This situation became even clearer during my first layer test. Although it wasn't enough to scrape the plate or cause a printing problem, I can say that the leveling wasn't very good. I also tried a few different settings. Right now, you're seeing the best result I've achieved. Remote connection works really well. I haven't encountered any disconnections or connection issues. Even with a cloud connection, you can view the print very smoothly. The camera is quite sufficient for print monitoring, but the quality is quite low for time-lapse videos. It's not adequate for professional social media sharing, but it can be used to observe the printing process. We've all seen the print quality together. If you ask me, the results are quite good, and it's also a stable printer. So it didn't cause any problems during the prints either. As I mentioned in the color test, I think it's at a level where it can directly compete with its rivals. In my opinion, the only thing that needs improvement for print quality is the cooling part. In some areas, I encountered slight sagging and stringing. Home and office users can be sensitive about noise, and sometimes the device needs to be placed nearby. Here's some good news. The Kobra X will definitely make you happy. It's one of the quietest printers I've used recently. Especially during color changes, it makes much less noise than its competitor printers. In my tests, I got results around 48 to 49 decibels. This is a very good result for speeds of 200 to 300 millimeters per second. I think this printer will find a good place for itself among entry-level printers. I was predicting that Anycubic would be on the rise in 2026. I guess, especially on the FDM side, it won't prove me wrong. Yes, that's all I have to say about the Anycubic Kobra X. I hope this video has been useful for you and has given you some ideas. I'm looking forward to your comments and any questions you may have about both the printer and this video. As always, I would be happy to answer them. May your printer run smoothly and your prints be flawless. See you in the next video. Take care. Daha ilk bakışta vurdun mührü kalbime. Yanarım sana, emeklerime yanarım. İşte kuzu kuzu geldim, dilediğince kapandım dizlerine bu kez gururumu. Ateşe verdim, yaktım da geldim.